Hello, everyone. I'm very pleased to be with you today. My name is Lionel Audouy. I'm working for Tecumseh. I'm managing the product development, product management for Tecumseh Europe, EMEA. And the presentation will be a presentation on the best refrigerant solution linked to the cooling capacity size. So the agenda, very quickly, I will go over the scope, because when we are speaking about cooling capacity, of course, it depends of the type, the size of the application. We will discuss about also the directives, the standards, regulation situation that we have today, or refrigerant roadmaps, what we would like to launch and what we have done since many years now. Some sub 150 solution. By sub 150 is a solution below 150 GWP. And some case studies where we will see what are the effects on the different application of this refrigerant, and the summary at the end. So the discussion, the scope of this presentation is linked to the application between 0 to 10 kilowatt, what we call commercial refrigeration. I will not speak about industrial business, only commercial refrigeration. And why is that? Because in fact, this market is quite huge in quantity, in turnover. Like you can see, we are speaking about 70 up to 80% in quantity, and also in turnover. So which kind of application? So the products that we are using, so we are a compressor manufacturer, so we are selling this kind of product to this, for this business. So we have reaching coolers, we have preparation tables, bottle coolers, display case, walkie-con room, ice machine. It's many type of application. It's a lot of diversity. And usually for this type of application, the key driver are simple, small. First thing, usually we are using a direct expansion system. So again, very simple. We have two different type of product, standalone or remote. It's a low maintenance, so usually it works up to the end with no intervention or minimum of intervention, and cost or price really sensitive. So here we have the scope where we are going to implement the next generation of refrigerant. Now about the directives and the regulation. What are we facing? You know better than me, certainly, that we have this F-gas that will be updating in the coming years, certainly next year, end of next year. A new proposal has been released recently with an increased phased-down quota. So we have an acceleration in the decrease of GWP. We have also some new bans for Jan 2025. It's only a proposal today. It's definitely a HFC phase out for 2027, if we respect this kind of proposal. And next year, we will have a lot of discussion with the European Community Parliament for a future adoption. It's not the only directive that we have today. We need to deal with other topics, like the Green Deal, the EU Green Deal, the Fit for 55. Today, Europe is pushing to respect some climate targets linked to the Paris Agreement. And they aims to make Europe the first climate neutral continent by 2050. So it's a huge target. So for that, last year, they released this policy proposal, Fit for 55, in July 2021. And it's minus 50% of greenhouse gases by 2030. So it's also a huge challenge for all manufacturers, an interesting challenge. And more recently, we have what we call a Repower EU. So it's linked to the disruption that we have in the global energy market, and mainly linked to what you know, to the war that we have currently in Ukraine. So the Commission has presented this directive, this regulation, Repower EU, for saving energy, producing clean energy, diversifying the energy supplies. Overall, what does it mean? Still, the market is focusing on low GWP refrigerant. So the main driver is low GWP. We have understood that. But now what we have, it's really a HFC phased on acceleration. We still have some people that are waiting up to 2030. We will see that we will have this kind of acceleration now. And a big priority that is coming is energy saving, so efficiency. It was a little hidden in the past. We were working much more on this refrigerant transition. Now, the efficiency is coming back. So free driver, low GWP, speed, and energy saving. On the standard situation for the commercial application, the main standard that we have today is a 60355-2-89. It's particular requirements for commercial appliance. And this standard has been recently updated with a higher level, a higher possibility in flammable refrigerant charge. So now, with this standard, you can use a higher charge of flammable refrigerant. Above this standard, so including, you have a wider standard, including this 60355-289 standard that we call the EN 378. It's a generic standard with a wider scope, which allow to be used on industrial system, but also on cold rooms and many other type of application. Usually, when you are not able to achieve and to respect this kind of level, you can jump on this one to put your product on the market. This update on this recent update in October 2022 for this 60355-2-89 allow now up to 500 grams of propane in Europe and 1.2 kilogram of A12. I just put some limit of flammability of refrigerant and some refrigerant like the R1234YF, the R454C, or the R455A, and the R290. These three refrigerants are A12. This last one is A3. Now, if you are not able to respect this kind of limitation, you can still jump on this one, linked to the size of the room where you're going to install the application. You can have a possibility to increase the charge. You have a graph with the 455 limits and 454C limits linked to the LFL, as I said. So you can see that linked to the charge, the volume of the cold room, for example, you can have a charge, a much bigger charge than this kind of standards. In conclusion, now you have all the standards allowing you to use flammable refrigerant. About the roadmap. It's a roadmap already presented 4 years ago in 2018. What we are focusing on, in fact, we are thinking that we need both solution, natural and synthetic, In natural solution, we have obviously propane, that is an excellent refrigerant, that is classified A3. We have also R600A, and for bigger installation, we have the CO2, that is a non-flammable refrigerant. On synthetic refrigerant, we are moving slowly, but we are moving from old high HFC refrigerant like 4,4A, 1,4A to a low GWP refrigerant classified as A2L like R1234YF, R454C, and R455A. These refrigerants are slightly flammable compared to the previous ones that are non-flammable. Some comparison about these refrigerants. On efficiency side, obviously, the R290 will provide a better efficiency compared to the A2L solution. It's what we have seen today on most of our application. On the system simplicity, direct expansion system, we have very similar approach between the A3 and A2L product. So we keep a system very simple. On the flammability, so the charge of the system, I will say that R290 is less compliant than the A2L on large application. So for us, refrigerant target, what we are working on today is to use R290 propane, so to push the propane solution on standalone application and on small and medium size up to the maximum of the limit that we can use linked to the standard. And for remote system, so split system, as with R290 higher than 150 grams, it's forbidden. At that time, and also for medium and large units with a higher charge, A2L is recommended, and we are pushing this kind of solution. So we push both solution, R290 and A2L. About the product, just to have a quick vision on the product size. As I said, we are manufacturing compressors. We have also a full range of condensing units. On the smaller size, so up to 7 kilowatts, for example, or 5 kilowatts, we have 4 different platforms available with R290 refrigerant in direct expansion system. We have also a full indoor condensing unit product range available. On the medium size, we have the full range of compressor, AJ, FH, AG, up to 10 kilowatt, available with these refrigerant, HFO, A2L, R1234YF, 455A, and 454C. Above 10 kilowatt, the market is moving to another direction, or we can still use R290 or A2L. We will find R290 in another type of solution. It's not anymore a direct expansion unit. It's with a secondary loop. It's what we call a chiller. And as the full quantity of charge is outside the building, there is no limitation on the charge itself, because we will have the secondary loop with water or glycol inside the building. Obviously, but in the bigger size, above 20 kilowatt, we can find a lot of CO2 system that is also a good solution. Now some numbers on some application, just to give you some results. We have done a simulation for a freezing remote system with A2L. So it's a cold room with an outdoor condensing unit. It's a cold room with 85 cubic meters. So the access category, it's linked to the EN378 with this kind of refrigerant. The cooling capacity is 3.5 kilowatt. So it's a supervised occupancy, so class B, and the condensing units, it's in open air, so outside, class 2. The refrigeration system charge will be, for this kind of application, 4.5 kilograms, and the standard will allow up to 7 kilograms, or just at the limit for this one, the 454C. So it's possible to use this refrigerant with this kind of application with the EN378. The same approach is on an application in chilling remote conditions, still with A12. So now we have 8.5 kilowatts. It's a room of 170 cubic meters. Also an outdoor condensing unit. With R455, R454C, so equivalent to 404A, we can reach a charge of 5.5 kilograms. And with an equivalent of the R154A, we have 6.2 kilograms. Meaning that it's much below what we will have in the, as limitation in the standard, in the EN378, with 14 kilogram, 9 kilogram, 9 kilogram. For an ice maker, so now it's a move from HFC to R290. So it's just, in this case, it was like a drop-in with some modification just to see the impact on the application side. We had a 4.4A, we moved to R290. First thing, we are going to reduce the quantity, the charge of the system linked to the characteristic of the refrigerant. We keep the system as much as possible the same. And as it was really to compare the two different refrigerants, you can see that when we move to 4.4A to R290, we will achieve a better high production rate, +4, +6%, with a lower power consumption, -3, -4% in this case. Another one, it's a proofing cabinet for bakery. This one is not a fair comparison because we changed the compressor, and this compressor has been optimized for R290, this one not for A12. Nevertheless, it's still interesting to compare. And it's very similar to what we had with the 4.4A, when you will have a charge half of the one that you have with A12 product with R290. And at the end, the R290 solution will provide a better cooling capacity and a better efficiency compared to the A12. Now we have done the same test with an optimized compressor, and we still have a drop in cooling capacity, but the efficiency is almost the same between the two systems. In conclusion, so the scope was 0 to 10 kilowatt. I'm not speaking above 10 kilowatt, so 20, 50, and so on. The priorities are low GWP, simplicity, speed, we want to go quick on the market, energy saving, efficiency. The two main solutions that we foresee currently on this size is R290 and A12, where for standalone application, R290 is a preferred solution, and when you have a limit in the charge of the system, you can move to A12. In remote system, the only solution for this kind of cooling capacity will be A12, as R290 will be forbidden. Thank you.